Hi everybody, hopefully this will be a quick video on just reviewing speed and acceleration in preparation for an upcoming quiz. So if you have your notes with you, or you could just follow along, you may remember that we went over, a couple of weeks ago, we went over motion, and we defined motion as a change in the distance between an object and a reference point. Okay, but hopefully what you remember from this lesson specifically is how to calculate speed, how to calculate the speed of something that's in motion. Now, speed is a rate, and we calculate speed by dividing the distance by the time. And it basically tells us, like I said earlier, it's a rate that basically tells us how much distance an object covered in a particular amount of time. Okay, and when we talk about an average speed, we talk about the speed, or rather the total distance covered by an object divided by the total amount of time. So it tells us, it gives us like an average of what the speed was throughout a journey. Now, I'm just going to go over 3 different types of examples that you'll get related to speed. One will be similar to what we saw here, and I'll just choose the first one. Okay, a rifle bullet travels at 5,000 feet in 4 seconds, and what's the speed? So this is a pretty straightforward one. We use our formula. Remember to always show your work. So our distance here is 5,000, and we divide by the time, which is 4 seconds. And that gives us 1,250 feet per second. Always remember to show your work, and always remember to have your answer with your units. Okay, box your answer so that it's clear. So something like this on a quiz would be worth, let's say, 2 points. Okay, if you're missing your work, you would lose a point. Just the same that if you had your work but had an incorrect answer, you would still get credit for that. Okay, so if we move on to another type of example that you'll get is this one, number 6. In number 6, we say we have a family that travels at 120 kilometers per hour on a road trip, and it takes them 5 hours to get to their destination. So here we're looking to find the distance, and I'm going to cover this problem right up here. So again, I'm using my speed equation. Okay, but this time I have my speed. The distance is what I'm looking for, so I'm going to replace that with the variable x, or that's our unknown. Okay, and we have the time, which is 5 hours. So here to solve for x, we would do x is equal to 120 times 5, and that'll give us 600 kilometers, which is our unit. So again, I've showed my work here. I have my answer with my units. The last type of example, and I just realized I wrote all over it, but nonetheless, the last type of example is this one here, number 4. Okay, number 4 basically says that Ariana covers a distance of 100 kilometers with her bike at a speed of 25. So we have our distance, we have our speed, and the problem says how much time does it take for her to cover that distance. So I'm going to do this problem down here. So again, I repeat, Ariana covers a distance of 100 kilometers, and she does it at a speed of 25 kilometers an hour. So if we use speed is equal to distance divided by time, our speed is 25, our distance is 100, and our time is x. X is our unknown, the variable that we are looking for. So then we just solve for x. 25x is equal to 100, and x is equal to, I'm going to do it the long way here, 100 divided by 25. So x is equal to 4, and our units are hours. Okay, so then again, always using this equation, okay, we can solve for any one of these 3 variables. We can solve for speed, we can solve for distance, we can solve for time. Always remember that I know that for some of you this comes really easily and very naturally to you, and that's great. Okay, always remember that I do want to see some sort of work on a quiz or on an assignment or whatnot. Okay, so I do want to see some sort of work with your answer. Okay, now I'm going to move on to acceleration. And acceleration is what we did last week. Okay, and acceleration is basically defined as a change in speed. Now, when we talk about change in speed, we can we can talk about or describe when the speed increases, or we can describe a decrease in speed, which is often referred to as deceleration. It's also referred to as a negative acceleration. Okay, so when we talk about acceleration, we can have an increase in speed, or we can have a decrease in speed, which we refer to as deceleration or negative acceleration. Now, the formula for acceleration is a change in v over t. The delta, this here, means change in. The v means velocity or speed. Okay, so if I write it out here, so it's final velocity or final speed minus the initial speed divided by the time. So this is basically telling us compare the two speeds, the final speed and the initial speed that the vehicle or the object started, divided by the amount of time it took to go from that speed to the next, and that'll give you your acceleration. Acceleration is also a rate, okay? And we also, the units for acceleration are always speed over time squared, okay? So it's speed over time squared, and we're going to look at that. You've seen that in these examples, and we're going to look at that in some of the examples that I'm going to go over, okay? I'm going to take the time here to go over some of the examples you've already done, and I'm going to use I'll use number 1 here. Okay, helicopter speed increases from 10 to 60 in 5 seconds. What's the acceleration? That's a pretty straightforward one. I'm going to use my equation divided by the time, the final speed. So the helicopter reached a final speed of 60. And I'm subtracting it by the initial speed. So when I started measuring the helicopter speed, it was already at 10. So I'm going to do 60 minus 10. That's its initial speed divided by the amount of time it took the helicopter to go from 10 to 60. Okay, and then we have 50 divided by 5. And then we have an acceleration of 10 meters per second squared. What this essentially means is that every second its speed increased by 10. It started at 10, after a second and reached 20, after a second after that it reached 30, 40, 50, 60. So after 5 seconds it reached a speed of 60 meters per second. That's what it's essentially saying. Now for number 2, same type of thing, but here we're going to get a negative answer. While traveling along a highway, a driver slows, there's our key word, from 100 to 52 in 12 seconds. Okay, again, following my equation, this time it's going to be 52 minus 100 divided by 12. 52 was the final speed. So because the helicopter was slowing down. 52 is our final speed minus our initial speed divided by the 12 seconds. So here we have a negative value, which totally makes sense because it's slowing down. And here we have negative 4 meters per second squared. Again, what does this mean? It means that the helicopter, but the driver was driving at 100 meters per second. And what happened is every second it would slow down by 4. So the next second it was at 96. The next second after that it was at 92, and so on and so on and so on. And after 12 seconds it reached a speed of 52. Okay, so this is what our answer is essentially saying. Now, other types of acceleration problems that you're going to get are such as number 6. Actually, let's do number 7 here. So in number 7, Peter is traveling at 25 meters per second. This is his acceleration, and he does it for 6 seconds. What is the final speed? So we're looking for final speed. Okay, so we use our equation again. We plug in the values that we have. We have our acceleration at 7. We don't have our final speed. It's x. Our initial speed is 25. And our time is 6. So we solve for x here. We're using algebra. 7 times 6 is 42. X minus 25. And x is equal to 67. meters per second, yes. Okay, so 67 meters per second was the final speed. So he started at 25, and every second his speed went up by 7. This is what this means. Okay, and the last type of example you'll get is something like number 9. In number 9, a cyclist accelerates at a rate of 7. So we have the acceleration here. How long, we're looking for the time, will it take the cyclist to reach a speed of 18 meters per second? So this is the final speed. Now in problems like this, you're probably wondering, well, they didn't give us the initial speed. And you're right, they didn't. In problems like this, remember, we can assume, okay, that the initial speed was 0. So if I plug in my values, I have 7. Final speed I have, it's 18, minus the initial speed, which is, I'm assuming, is 0, and divided by the time. I don't have the time, that's what I'm looking for, so that's my x. So 7x is equal to 18, x is equal to 18 over 7, and x is equal to 2.67, and our time is in seconds. Okay, so again, these are the types of problems you're going to get here, okay, where you're given the acceleration, but you have to solve for the unknown. And I hope this was helpful.